Today's video will talk about the client-server architecture. Hello, I'm James Helfrich. Probably the most common layered system design architecture is the client-server architecture. This video will talk about several major design considerations that need to be made early in the design process. It will not cover the technologies of the client-server architecture, but rather describe how to design them more effectively. Okay, just to get a big picture of what we're talking about here, there are three main architectures. There's the client-server, the end-tier, and the peer-to-peer. Now, what makes the client server unique is that a client server has exactly two components, and the two components serve a different role. So in the vast majority of client server architectures, we have the client who is customer or user facing, and we have the server which contains the data and does most of the processing. The server, also known as the host, the backend, the data access layer, or the service provider, is the component providing functionality to the client, whereas the client utilizes the server's functionality. Now, notice that the server is almost always the provider, and the client is always the required component of the interface. The first major consideration is how many clients and how many servers there are. In the simplest scenario, there's exactly one client and one server. In the second scenario, there are many different clients and a single server. In the third scenario, there is one server and many different clients. And in the fourth scenario, there is a many-to-many. Let's look at each of these in turn. So in the simplest scenario, when there's exactly one server and exactly one client, then the client knows exactly what the server is going to provide, and the server knows exactly what the provider expects. An example of this simplified architecture is a bicycle, believe it or not. On modern racing bikes, you have a power meter which collects power data, and then there's a bicycle computer which collects the data, stores it, and presents it to the user. Now, in this scenario, the bicycle computer is actually the server because it does all the processing as well as stores the data, and the power meter on the pedals is actually the client. Now, there's exactly one client, there's exactly one server, the relationship is well understood, so it's really easy to design this interface. It is far more common to have the second type where there's many clients to one server. For an example, you may have a social media platform that has a web interface, that has a iOS web interface, and an Android interface. Here we have three distinct clients, all talking to exactly the same server. Now, this puts an extra load on the server, of course, because it has to understand the different needs as well as perhaps different features for the different clients. Now the server has to decide, are we going to make all the clients use exactly the same protocol, or are we going to offer different protocols according to the changing needs or the different needs of the clients? And this is a decision we have to make early in the design process. Another example, if you have one client talks to many different servers. For an example, you may have a web page that takes the data from one server, the advertisements from another server, and the social media connections from yet a third server. Now the client has to manage perhaps the different communication protocols, as well as the different functionality needs of the various servers in order to function correctly. The final scenario is a many-to-many, and this one is perhaps the most complicated, and your cell phone is a really good example of this. Here we have the client, which is the phone, and it's going to have many different versions of it depending upon the different apps you have on the phone. And then it's going to talk to many servers, maybe your social media, maybe your email, maybe your weather, maybe your stock ticker. This many-to-many relationship means the client has to be able to talk to many different types of servers in a very generic protocol, as well as the servers have to deal with many different kinds of clients. This is by far the most complicated. Now, the second major design consideration that needs to be made is going to be, you're going to have a thick client or a thin client. We need to define that. Now, a thick client is one that does most of the processing and contains the data on the client side, whereas a thin client has most of the processing and the data is on the server side. Now, in the early days of the web, everything was a thin client. The web browser didn't have the capacity to run code, it just presented static HTML pages. So the server had to have all the data and perform all the computation and simply sent static web pages up to the client. Okay, so let's take a closer look at the thin client. So we're going to start with the client, then we're going to have the server, and then we're going to have the user. Now the user is going to initiate a request to the client, and then the client is going to need to get the code from the server in order to operate anything. Now, normally that code comes across as JavaScript or thing like that, so that that code is thrown away as soon as the request is made. In other words, every new page request is going to result in a new copy of the code because the code is embedded in the client, and that code is throwaway. And then the UI will initiate a request to the server to get some data, and then with that data, will then interact with the user. Now, a couple things to notice. First of all, seldom is there code in the client is persistent, And second of all, seldom is there data on the client that's persistent. All the code comes directly from the server, and the data comes directly from the server as well. An example of a thick client is your word processor. It contains the data on the client, it does all the processing on the client, and then only occasionally sends data over to server when it needs to be permanently stored. All right, let's take a look at how this goes. We have the client, we have the server, and then we have the user. And the user fields requests from the client, but the client has absolutely no code but needs to get the code, so it's going to talk to installation service. The installation service will then get the code and send it to the client, and now the client has some UI code. In the next step, the user will then interact with the user interface. The interface now has a copy of the code because it downloaded it, and it will then talk to the server, get the data, and then often have a copy of the data itself. The important thing to note is usually the code is on the client machine longer than it is in the thin client. In other words, we install an app or something like that. And the second thing to note is oftentimes the data itself is stored on the client, perhaps even the majority of the time. And maybe the server only has a backup of the data or keeps a permanent copy of the data, but the working data is kept on the client machine. Now, of course, many applications are somewhere between. One example of a thin client, surprisingly so, is the first few versions of Outlook, where much of the processing was done on the client side, but all the data was on the server side. The minute you drop the network connection, then Outlook would stop functioning. And then in 2000, Outlook introduced something called the local store, and it's created a cached version of the data so that it can operate in a partially connected environment. So if you lost network connection, like on your laptop, then it could function for a while using your cached data. And then as soon as the network connection is reestablished, then it sunk everything up. That means it would send your email and refresh your inbox. Now in the mirror client scenario, we have the client, we have the server, and then we have the user. And the user is going to initiate a request, and then that's going to go straight to the server, and the server is going to get the data. Now, what makes this one distinct is the client will also keep a copy of the data. The important thing to note is that cache is a copy of what's on the server. Now, if the connection between the server and the client gets severed for any reason, the client can still operate on the cache, but needs to periodically update that cache with the server. This means we have to know which copy is more recent, the client or the server. We have to be able to know when the cache has been invalidated and need to request a new copy, or when the server data needs to be updated. This cache management situation is non-trivial. So my question for you is, how thick should the client be? If the client is really thick, you have to deal with some things like keeping the client code up to date or downloading the client code or having to go through installation process. If you use a cache design, then you have to figure out how to invalidate the cache and what do you do with the cache conflict. And if you use a thin design, then you have to worry about the partially connected environment as well as the server load. Each of these are considerations need to be made early in the design process. You can learn more about the client-server architecture and the client-server section of the Layered System Design chapter of the Software Design textbook.